Okay, so continue from volume of cube. So as I said that the this value, see previous lecture, this value basically is the approximated or tolerance. So tolerance may be in positive or negative. So I will write that d of x will be less than equals to 0.1 or greater than equals to negative 0.1. Okay, as this is cube, so my geometry is cube. So the volume of cube is x cube, that is length multiplied by breadth multiplied by height. So I have to take the derivative because I have to estimate the error. So it will be dv will be equals to derivative of v with respect to x is 3x square. Then I have to multiply this here. So it will be dv equals to 3x square with the value of derivative, that is p of x. Now I will put these values. So what is the value of x? X is the original measured value, that is 5, and v of x is tolerance value. This value is positive and negative respectively. So I will write that dv when tolerance value, that is d of x equals to 0 positive 0.1. So my dv will be 3 into uh, x is 5, so it will be 5 square with the value of d of x. So d of x is positive, so it will be 0.1. So this is positive 7.5. Okay, but there is also negative 0.5. So I have to find my value with respect to d of x equals to negative 0.1. So it will be again dv equals to 3x square into d of x. So d of x equals to negative of 0.1. So I will put the value dv equals to 3x is 5 and d of x is negative 0.1. So this value is negative 7.5. So this is the value positive 7.5 and d of x equals to 0.5, and this is negative 7.5 at d of x equals to negative of 0.1. So my approximated value will be dv will be less than equals to positive 7.5 because this is the upper limit, and it is greater than equals to negative 7.5. The value of t. Okay. So for the second part, I have to compute the volume of the cube if the side length is 4.9 centimeter and 5 point, and then compare the estimate error with the actual potential error. Okay. Let's say for the first case, if the length equals to 4.6 centimeter. Okay. So my value will be v of x will be, as I know that it is equals to x cube. So v of at 4.9 centimeter will be equals to 4.9 cube. So it will be, the value is 117.649 centimeter cube. So next will be volume of 5.1 centimeter. So it will be 5.1 whole cube this will be 132.651 centimeter cube. Okay, so this is the part number B. So I have to compute this part B with 0.1, that is 4.9. My value is 117.649, and with 4.1, 5.1, sorry, my value is 132.651. Now I've compared the estimated error with actual potential error. So what this? Okay, so I have to write that the actual volume of cube is between these two values, that is 117.649 and this one. So this is the lower limit, this value, and this value is the upper limit. So since the side length is measured to be 5 centimeter, which is given to us in the question. So V at 5, so it will be equals to 5 cube, that is x cube. So V cube will be 125 centimeter cube. Okay, now this is the actual value. This is the actual value. And this is, these two are part 1 and 2 are the approximated value at 4.9 and 7.1, 5.1 respectively. Therefore, the error will be, now for error delta V will be my approximated value, that is 132.65 at 5.1 minus volume at 5, which I find is 125. So I will write here that delta V is less than equals to the upper limit. Upper limit is 5.1 minus V of 5, and it is greater than equals to V at lower limit is 4.9 minus V of 5. Okay, so it will be 132.65, this one, minus 125, and then 117.649 minus 125. So this is why delta V with positive and negative limits having upper and lower limits. So we can estimate error dV is respectively close to actual potential error in the computed volume. So this is the actual dV is dV I found in first cases 7.5, limit is from positive to negative, and by estimating it, it is 7.651 to minus 7.351. That is, my range is this one, and my value will be 9 between them. So it will be 7.5 respectively. Okay, now next is relative and percentage error. An astronaut using a camera measures the radius as 400 mi with an error of plus minus of 80 mi. Let's differentiate to estimate the relative and percentage error of using this radius. This radius measurement to calculate the volume of Earth, assuming the planet is a perfect sphere. Okay. Now for this case, the radius is accurate within this limit, that is plus minus 80. So plus minus 80 is my tolerance. Okay. So I will write that this is the tolerance in radius. So upper limit will be positive 180 and lower limit will be negative 180. And the planet I assume is perfect sphere. So volume of sphere is 4/3 pi r cube. Okay. So it will be 4 upon 3. My volume is 4 upon 3 pi r cubed. And so it will be dV upon dr. This will be 4 upon 3 pi is constant, and I have to differentiate r. So it will be 3r square. Okay. Now I have to, this 3 is divided by this one. So it will dV equals to 4 pi r square. dV upon dr equals to 4 pi, and then this dr is multiplied here. So dV equals to 4 pi r square into d of r. Now using the measured radius of, now the measured radius is what? As I described earlier, this is 4 pi, and the value of radius is 4,000 with radius 80. With radius 80. So this is the upper limit, okay, that is 4 pi, this one, this is here, and the lower limit is negative of 4 pi 4,000 into 80. I will write this. To estimate the relative error, consider dV upon P, that is change in volume divided by total volume. Since we do not know the exact value of V, so I will use the radius value, that is 4,000, to approximate. As we know that the volume is 4 upon 3 pi r cubed, so I will use this value. So in this step, I have to differentiate this step with respect to b, that I have to divide whole fraction with b. So it will be like this. So in the lower part, it will be 4 pi, then 4 upon 3 pi, then r cubed. So this is the value of volume, and this is also the value of volume. So after the calculation, so it will be dV upon B, that is change of volume with respect to original volume is less than equals to 0.06, and it is greater than equals to negative 0.06. Okay, so the relative error is this one. So I will take the positive value. So it is 0.06. So 0.06 is what? Relative error. Okay, so this is the first part to find relative error. Now I have to find the percentage error. The percentage will be 0.06 multiplied by 100. So it will be 6%. So 6% is what? Percentage error. So this is the final example of my error approximation of relative and percentage error.